So in today's class, we are going to actually look at how to define classes in Python and what uh, classes are, how do we use them, how do we define them, and how do we use them, right? So this is what we are primarily going to cover. This is relatively a smaller module, so what we are going to do is we will be using Python to create classes and objects, and then we will see what is simple inheritance and what is multiple or multi inheritance. So with that, let's get started. So I have already created a Jupyter notebook, which I'm going to use to actually demonstrate all of this concepts, right? So let's get started. How do we define a class in Python, right? So to define a class, we use the keyword class, right? See, this is a keyword. That is why it is appearing in bold green. So class and then the class name. It is the same definition wise, right? Or syntax wise, this is the same as how you define a function, right? So in function, you say you write def and function name. To define a class, we write a class and then a class name. So what do we do when we define a class? Inside a class, there could be two things, right? So inside a Python class, there could be two things. So let me just help you understand this and then we can look at the code afterwards. So when you define a class in Python, right? When you define a class, then what all things it can contain? It can contain, first of all, variables. We also call them as properties. And then we can have functions or methods. So the first question that must be coming to your mind is we have been defining variables. We have been also using functions. But then why do we define them inside a class, right? Why define a class? So this is why define a class. That is a very first question. So there is a concept, right? There's a concept called encapsulation. Just a minute, guys. So there's this concept called encapsulation, right? Now, what do we do? When we do encapsulation, right, what is it that we are trying to do? We're trying to hide the implementation logic from the user, right? This is what we try to do. Now, what does it mean? Let me give you an example. So when you call the math.sqrt function and specify 25, it gives you 5. But do we really know how it is calculating the square root of 25? We really don't know, right? So we don't know the implementation, right? So what does it mean? It means that there's this maths, which is called a class, which is actually a class, sqrt, which is a function, right? This is a function. Where is this function? This function is inside this class, right? So this function is defined inside this class. We can just call this function by writing class name dot function name and pass it some value, and in return it is going to give me something. But do we really know how it is converting 25 to 5? We really don't know. When you specify 36, it is going to give you 6. When you specify 49, this is going to give you 7. But do we really know how it is calculating the square root of 49 or 36 or 25? We really do not know. And this is what we mean by encapsulation, which means we hide the implementation logic. We hide the implementation logic from the user. So what is happening in maths.square root? When you call math.square root, then you are actually calling this class, and then inside that class you have this function, and you're actually calling this function, right? And you're passing the value, whatever value you want to specify. It is going to give you 4. So how is it, why is it important? At times you may want to perform some action, but you may not be interested in knowing how that action is getting performed, right? So here I'm only interested in knowing the square root, right? Or calculating the square root of a number. But I really do not know. It does not really matter to me, right? It does not matter to me. Let me just write it a little more clearer, right? So it does not matter to me, right? So what are the two things that I need? I need to know the square root. That is one thing that I need. And do I really care how the square root is getting calculated? Not really. I do not need to know how it is getting calculated, right? So for things like these, we actually define classes where we want to have the user use some of my modules that I have defined, but the user is actually interested in just using it and not knowing the implementation details, right? So this is a brief overview of what a class is and how and why we need a class, right? One thing which is very important here to you for you to understand is class is used to do encapsulation, right? And what is it that we encapsulate? We will just see. We encapsulate these two. We encapsulate the variables as well as the functions. So a class is primarily consists of, right? It consists of variables. We also call them properties, or it can consist of functions. We also call them methods. So let's see how do we define a class in Python, right? So to define a class, we use the keyword class, right? And then we specify the class name. So the class that we are trying to define here is going to be having a name student, right? And what are we trying to do? We are just defining three variables. Name is equal to space or blank null, age is equal to 0, and gender is equal to nothing, right? So when we execute this, it is only going to just define a class and not do anything. So let me do one thing. Type of student. Let's see what happens, right? It is saying type, right? So when it says type, actually it is a data type, right? And it is actually a class. To be able to understand or to be able to figure out if there is an object which exists for this class, we will need to actually define a object of this, right? And this is what we are trying to do. What is it that we're trying to do? We are defining a variable named my student, right? And is equal to, what is it that we have written? See, this is nothing but the name of the class itself, student, right? And we are not passing any value. Now what is happening? Let's see. It did nothing, right? It just created an object of the class, right? My student is an object of class and the name of the class is student. Let's do one thing again. Let's print the type of my student now and see what happens. See, it says main dot student, which means this is a my student is a, what is it? It is a an object of this class, student class, right? So Okay, now what will my student consist of? It will have three variables, right? Name, age, and gender by default. Why? Because when we defined the class, we defined the class with three variables, right? Or three properties. So whenever we define an object of this class, which is my student in this case, this my student will have all of these three variables available with them, or all of these three properties available with them. And that is how classes are actually used. A class cannot be used as such. You first need to define an object of the class. How do you define the object of the class? You define an object name or variable name is equal to, and then specify class name, open parenthesis, close parenthesis. You must be wondering, why are we using opening and closing parenthesis, right? Because your confusion would be that student is not a user defined function, right? It's a class. But then this is how you actually define an object of the class, right? You specify opening and closing brackets after the name of the class itself. So let's see what happens. This has done nothing, right? But then it has created a class of my student object, and that is of class student. Okay, now I told you already that when you define a object of the class, then all the properties or functions will be available to this object as well, right? How can I say that for sure? So initially when we defined the class, it has nothing, right? Name is equal to blank, age is equal to 0, gender is equal to blank. So let's try and set these values, right? For this student, my student, right? So what I'm trying to do to set these values, I'm using my student dot name is equal to, I'm specifying a name, Ajay Kumar. Then my student dot age, I'm specifying the value as 30, and my student dot gender is equal to male, which means I'm specifying a value of male to the gender. So let me execute this and see what happens. So nothing got changed, nothing printed, because what I'm trying to do is I'm setting the name value, age value, and gender value for this object, which is my student, right? And how can I access it? Again, we can use the same in a print statement. So we can print my student dot name, my student dot age, my student dot gender. And when we print this, see what is happening. It prints the same name which we set for the my student name variable. It prints the same value which we set for my student age variable, and it printed the same value for my student dot gender, which we set here, male, right? So so this is how it works programmatically. But then let me go back to the whiteboard and show you exactly what has happened here, right? So what has happened here when we defined the class, then what actually happened, and when we created an object, then what happened, right? So class in this case is nothing but a data type, right? The way we have an int variable, the way we have a character variable or boolean variable, the same way class is also a data type. So when we define the class student, right, and we defined name is equal to nothing, age is equal to 0, and gender is equal to nothing. So when we defined this, right, what happened? This class itself became a data type. This class itself became a data type, and the name of the data type is student. Name of the data type, student, right? Okay, so how do you define a variable of any data type, right? The same way we can define the object of this new data type, which is called student. Now how do we do that? So when we say student 1 is equal to student, then you defined an object of this new data type, which is student. You can also define another data object, right? And again use the Same syntax. Student2 is equal to student. Std3, student3 is equal to again student, right? So we can define all of these. Now what are these? What are these? These are, so this is the class name, right? And these are my objects of the class. So what are these objects representing? This object is representing one student, right? This is also representing another student, right? For simplicity's sake, let's say call it student 1. This is student 2. And this object is representing another student, student 3. This student will have a name, a age value, and a gender value. The same ways, this student will also have a name, it will also have a age, and this will also have a gender value. Same ways, student 3 will also have all of these three variables available with them. So age, name, age, and gender values. So this is how it works. When you define an object, it becomes a variable of this class, and this is how it works. Do let me know if you guys have any questions so far, because if you understand this correctly, then we can proceed further. Any questions what we are trying to do here?
No, no, Manish.
Okay, so how is this beneficial, right? Why can we not only define the name, age, and gender? Why do we need to specify this inside a class, right? So one benefit of it is that you can actually hide the implementation from the user. The other benefit is you can use this as a template, right? Later on, if you want to add, let's say, another variable, right? Roll number. Roll is equal to all of these students, student 1, student 2, and student 3. What is the best way to do this? We can just add this inside the class and not worry about defining them separately for each of these students, right? Right now we are only talking about three students, but what if we have hundreds of students records? How can we add roll number for all of them? The easiest way would be to define them inside the class itself, right? And this is going to be very helpful. So this is the theory of it. Let's go back to the implementation part, right? And let's see what we have done so far. So we defined a class, right? So we have defined a class, right? It has three properties, name, age, and gender. With and then we have defined the object, right? So let me define object of the class student. So this is all going to be case sensitive, so you need to be very much aware what if your class name starts with initial caps or it is, initial lower caps. Then we have set these values and then we have printed those values, right? So I think we should be all clear so far. So, okay, that is done. Let's look at another implementation of the same class, but here we will be creating the object in a slightly different manner, right? How is it going to be different? So define an object using the constructor method. So how is it different, right? See, earlier when we had defined an object, we had written my student is equal to student. And to set the values, we use these statements specifically. My student dot name is equal to, we specified a name. My student dot age is equal to 30 and my student dot gender is equal to male. But now if you look at this line, we are defining an object of the same class which is named new student, but instead of specifying this as student opening and closing brackets blank, we are actually passing all the values here itself. So we are passing a name value, we are passing a age value and we are passing a gender value, right? So how is this going to work? See, we have not used anything like this. We are not going to use this. We are passing all of these values, name, age, and gender here itself, right? And this is how this is going to actually work. And you must be, uh, able to understand, right? You must be able to understand that defining this way, defining an object of a class this way, and passing all the values simultaneously is definitely going to be more readable and more easily understandable than actually doing it this way. So how is this even working, right? How is this even working? Think of this as you calling a function where you are specifying or passing some parameters, right? And what are these parameters? All the three values of the class, right? Of the properties of the class. So how does it work? There is something called as a constructor method, right? Constructor method. So what does it do? A constructor method, what does it do? A constructor method is used to initialize the values of the class. This is what it is supposed to do. So what are the values? Initialize the properties of the class, right? So what are the properties that we have? We have name, age, and gender. So what is that constructor method? This is the constructor method. What is the name? It is underscore underscore init init underscore underscore. This is a predefined name. You cannot change it. And how does it work? It has a by default parameter which is called self, right? Which is an object of the same class. And then we can pass on as many variables to this constructor method, right? Now, this list should match the parameters that you pass here. And what is this doing? Actually, this is setting the self.name. Self.name will be this name is equal to name, this name, the name that you're passing. So what is going to happen? When you call the constructor method, right, and you're passing the first value as Amit Kumar, then this is going to get received here, and this is going to get set as the name. When you're passing 25, this is going to get received as age, and then this is going to get set as whatever value of age you have specified. And this is going to get received in the last parameter, and this is, if you look at it, getting set as the gender for this student. So that is how it is actually working. If we are passing while creating the object of the class, right? We're trying to create the object of the class. If we are passing all the values for all the properties for the class, then you should assume that there is a constructor method which is already defined, and this constructor method is actually setting these values. So earlier, how we were setting these values? We were setting these values by specifying them explicitly, right? We were setting them explicitly outside of the class. This was not part of the class. See, these statements are not part of the class. But now the init method is very much part of the class, which means when we define the class, this init method is also getting defined, right? And this init method belongs to this class named student. So this is the only addition, right? Earlier when we defined the class, it just had three variables in there. Now, when we are redefining the class, we are not only confined to three variables, we are also including a constructor method, right? Class with constructor method underscore underscore init underscore underscore. So this is what it is doing. Okay, so this is a constructor method, right? So we have defined the class and then we have also defined the object new student, right? With all of these values. Now let's see if I now print these values, then what actually gets printed. So it prints Amit Kumar 25 and male, right? Is it not the same as what we had passed? Yes, it is. So what does it mean? It means that I can actually while creating the object of a class also pass all the values for the properties of the class. And when we do that, actually we are using a constructor method named underscore underscore init underscore underscore to set the variables of the class, right? Or the properties of the class. So this is a better method, right? Because it is more self-explanatory, and then we do not necessarily need to write those explicit these statements to set these values, right? The other thing is that this method is also inside the class, and all the properties, right? All the properties and all the functions, they should all belong to the class, right? And that is how it is more structured. Any questions with the init class and why we are calling it a constructor method? Anyone?
No, no Manish.
Okay. All right. So, all right. So just to summarize, the reason we are calling this a constructor method is because we are using this method to construct or initialize the values of the class, values of the properties of the class, right? Okay. So these are the two ways. Now we will actually keep extending this class, right? So in today's class, we started with a very simple class example, right? Then we added a init method, a constructor method. It is the same example which I'll continue to extend, right? I'll keep adding more and more things to this class so that we do not have to worry about uh, remembering the definition of multiple classes at once. So let's extend this further. What is happening right now, right? We have when we need to fetch the values, right? These values we are able to fetch by using object name dot property name, right? Object name dot property name, object name dot property name. But this is not the correct way of accessing the properties of a class. We should define a method which returns these values, right? So let's see what we can do. So we have seen it all so far here, right? That this is not new. What we are doing is we are defining a get name function, and what is it that we are returning? Returning self dot name. So we have defined a function to return the name. Then the same way we have defined another function to return the age, right? We have called it get age, right? It could be anything. You can specify any name, right? This is a user defined function. So you can specify any name. Get underscore age, return self dot age. Get gender, return self dot gender. So let me define this. What we have done is whenever we want to print the name, we will instead of writing student.name, we will call this function, and that is how it should be defined. Whenever we need age, instead of writing my student.age, we will write my student.getAge, right? And this function is going to now give me that age value. And same ways for the gender. So let me define this first, right? So already defined, and this is working fine. No issues as such. So this is done. Okay. What we should do now? We should then create a object of the class, right? So now we are taking a different name of the object, right? New student is equal to student, and then since we have a constructor method, right, we can just specify name, age, and gender. So we are specifying the name as Aman Sharma, age as 22, gender is equal to male, right? So we did that. Now, so we have, what is it that we are using? Let me just specify this. Define an object and initialize the properties using the constructor method, right? This is what we are doing. Now, what are we doing here? See, earlier to print the name, we were using object name dot name, right? But now we are not doing that. We are calling the user defined method in class student to return values of the initialized values of the properties, right? So what is the name that we had initialized it with? Aman Sharma, right? Let's see what happens when we write new student dot new underscore student dot get underscore name. See, we're getting the same name, right? Which we had initialized it with. So will my other statement work, right? If I write just name, will it work? See, this is working as well, right? This is working as well. We have used this earlier, right? We have used this earlier. That method is also going to continue to work. But what we are trying to learn here is that instead of this, we are going to actually use this user defined function to return the name. And that is how it should be. Get name. The same ways when we do get age, this is going to return you the age, right? 22. And then when we specify get gender, then this is going to give you the gender as well. So what have we done now? If you look at the class, this is the name of the class. These are the properties of the class. So these are the three variables inside the class. And then we have four methods inside the class. This is a constructor method, which is actually getting used to set the values of these variables. And these independent functions, right? Get name is actually returning the name, get age is actually returning the age, and get gender is actually returning the gender. So in a sense, if you look at the whole code, this may look like pretty big and complex, but then this is a very simple piece of code. What we are trying to do here is we are defining a class with three variables. We are just setting the values and returning their values independently. Clear? Any questions so far? No? Okay. All right. So let's move on. Let's move on and let's add some little uh, logic in here, right? So class with user defined functions, right? Again, like told you earlier, I'm just going to keep extending the same example. So now if you look at it, again the same class student, then we have name, age, and gender. These are the three variables. We have already looked at it. This is my constructor class to set the values. This is my get name uh, function to return the name, get age to return the age, get gender to return the gender. Now, in addition to this, I have also defined another thing, and this is the new addition here, right? Is senior citizen. This is a function, right? This is a user defined function. And what is it that I'm doing here? If self.age is greater than 60, then return true, else return false, right? So what is it that I'm trying to do? For this student that I'm talking about, this function is senior citizen is going to return true or false, depending on what the person's age is. So if the person's age is greater than equal to 60, then this is going to return true, else this is going to return false. So let's see if it works. So how do we define a object, right? Object name is equal to class name and then specify the values for the properties. So we defined, let's first define this. So I defined the class now, which looks pretty bigger now in terms of definition. Then I specified the students details, right? So Raman Singh, name, 65, age, and male, gender. Now what I'm trying to do, I just want to invoke this function and find out what this function returns. I'm expecting that since the age of the student is 65, which is greater than 60, it should return me true, which means that this student is a senior citizen. So let's call this and see what happens. This is returning true. But in case if I had set the value of age for this student to be less than 60, then the same function would have returned you a false. Right? Getting the difference? Guys, getting the difference? Let me let me define two different students so that you can make a distinction between the two. So first one is Raman Singh, the second one is Rama Singh, right? And we can probably, yeah. So Raman Singh, whose age is 65, is a senior citizen, true. And Rama Singh, 50, female, is not a senior citizen, false. So what is happening, right? All the methods are inside the class now, which is actioning upon these variables of the class or the properties of the class. So let me go back to the same whiteboard again and help you understand as to what we are trying to do. So we are actually defining a class, and then inside the class, this is the name of the class. Inside the class, we are defining variables, variable 1, variable 2, and then we are defining functions. Function 1, we are writing something in here. We are defining function 2. Again, we have a function definition. And what are we trying to do? Everything that we are doing with these variables, these are all happening inside either this function or this function. And when we define the object of the class, right? When we are defining the object of the class, right? Object name is equal to class name, right? Whenever we're defining it, we are not calling these variables directly. We will not use object name dot variable 1. This is not what we are going to use. We are not going to use object name dot variable 2. This is not what we are going to use. Instead, what we will use is object name dot function 1. This is correct, and object name dot function 2. We are going to use these, and whatever happens with variable 1 and variable 2, these all happens within these two functions. So this is definitely not allowed. This is definitely, this will work, but then this is not an ideal standard. This is what you should not be using, right? So this is what is happening inside the class. We define variables, and then we define functions which perform actions on these variables, and we do not perform actions on these variables outside of this function, and that is why I have written that this is not a good practice. This is a good practice. We should do everything with the properties using the functions which are defined in the same class. So using a variable 1 here is all right. Using variable 2 here is all right. Same way, you can use variable 1 here. This is all right. This is also all right. All right, so guys, do let me know if you have any questions as to what classes consist of, why do we create them, how do we create them, and how do we use them. If you have any questions, then we can take them. Otherwise, we can just move on. On your screen right now is a very standard definition of a class which has three properties and then a constructor method to set the values and then individual methods to perform any kind of a action on these variables itself, because we do not want to refer to these variables outside of the object. Do let me know if you guys have any questions.
No, no Manish.
Okay, all right. So let's move on then, right? There's something called as, and this is probably the next topic that we have is inheritance, right? Simple inheritance and multiple inheritance, right? So let's look at what a inheritance is. So it is, in a literal sense, you can refer to how inheritance is, right? We inherit stuff from our parents, right? Our grandparents. The same way we can define classes where a class can inherit from another class as well. Now, how does this work? So we can define a class. Let's say we can define a class A, right? What will it have? What will this class have? This class will have properties, right? Let's call it, it has two properties, P1 and P2. This class will also have methods. Let's call them as method 1 and method 2. Now you can define another class in a manner that it inherits from class A. When you define this class such that it inherits from class A, then what happens is whatever is available inside class A is by default available in class B as well. This all gets inherited, right? Which means what is available in class B? First of all, it will have P1 and P2 because these are being inherited. And then you can also add on top of this P3 and P4. You can add. I'm not writing add, but then you can define them separately in class B. So class A will continue to have two properties, P1 and P2. And class B will have four properties, P1, P2, because it inherited these from class A, and then you separately defined P3 and P4 in class B. So class B will have four properties. Same way, when you look at methods, methods will also get inherited, right? M1, M2, and then you can on top of that define your methods M3 and M4. Now, to do your data analytics, maybe inheritance is something which is going to be a little hardcore and you may not be required to use them. But then as a concept, you should just know, right? It is definitely not, 100% must that you know and master the concept of inheritance. Just know that there is something called as inheritance. And the code which I'm actually taking this, taking today as an example to demonstrate is also going to be very simple so that you just understand this concept, right? So far we have just defined one class, right? Class student, right? And then there is no inheritance. We defined a class and then we defined the object of class, right? And then we called the method of the class, and that is pretty much the standard way of handling a class through an object, right? But now what we are going to do is we are going to actually see the concept of a simple inheritance, right? What is happening in this case? Class A is getting inherited into class B. And this is example of a simple inheritance, right? You can think of this as, you know, usually the keyword that is referred to as is parent and not father, but then, a son inheriting something from the father or a child inheriting something from the parent is how it is called. So this becomes the parent class and this becomes the child class, right? So in this case, whatever the parent had gets inherited into the child class. So when you have this kind of inheritance, we call this as a simple inheritance. And there are other ways of inheritance as well, right? If there is class A and you inherit this into class B, this is simple inheritance. There could be another examples, right, where you have class A and class B and you define both of these classes simultaneously into class C. So this is simple inheritance. This is called multiple inheritance, and there is something called as multi-inheritance where you can have this kind of a multi-level inheritance. If you have this, then this is called multi-level inheritance, right? I think the diagram is a little simple, right, to understand, right? This is simple. One class gets extended into another class. When more than one classes gets inherited into a single class, right? Then this is called multiple inheritance. You can think of this as a person, right? Just as an example, right? Who is inheriting something from his uh, paternal side as well as maternal side, right? And then this is uh, a multi-level inheritance where this is, you can think of this as grandparent, right? Which is being inherited into the parent class, and then this is finally getting inherited into the child class, right? This is how it works. Now, how do we implement this? What we are going to do is we are going to look at two examples, one of a simple inheritance and the other one of a multiple inheritance, right? And I'll just leave it on you guys to implement the multi-level inheritance. So let's quickly look at as to how we can implement this. Now the syntax is very simple. If you understand these concepts, if you understand this concept, the syntax is going to be very simple. You define two classes, class A and class B, and there's a little tweak which we do to specify that one of the classes is inheriting the other class, right? So let's look at this. So I've kept a very simple example here, class A, name and age, right? So what are we doing here? We are defining first class, right? The name of the class is A, and we have just two variables in there, name and age. Now, what is different here, right? If you look at this, we have defined class B, right? And actually, ideally, I should have defined class B as this, right? Class and the name of the class B. But there is a slight difference here, right? I've specified small brackets, and inside the small brackets, I have written capital A. Now, what is capital A? Capital A is my another class which I have already defined. So what is it that I'm trying to do, right? If you get this correctly, what is it that I'm trying to do? I'm trying to inherit class A inside class B, right? So what I'm trying to do, I'm exactly trying to do this one. I'm trying to inherit class A inside class B. And this is an example of a simple inheritance, right? So how do we inherit classes? Again, the syntax is very simple. You just specify the parent class name while defining the child class, and that is one way to inherit one class into another. Okay, so let's look at the two classes first, right? Name and age exist in class A, and class B has gender and a function called is senior citizen. We already know what this function does, right? So I'm not going to the details of it now. But what do you think if class A is being inherited in class B, then is name and age available in class B or not? What do you guys think? Anybody? Is name and age available inside class B or not? We have defined this class B as if we want to inherit class A in there, right? So
Hmm. Yeah, it will be available.
it will be
Yes.
available because this is the example that I showed you, right? If you inherit something in another class, then all of the parent class properties are available in the child class, right? So this is going to be available. Now, how do we prove that? So to prove that, what we will do is, now we are not going to create the object of class A. We are not going to do that. We're just going to create the class of object of class B, right? So look what we are trying to do here. We have defined a object named std, right, student, and we are calling the class b, right, without any parameter, which is defining the object of class b. Look at this. When we specify std.name, right, and specify a name, right, does this work? Let me first define the class. Does this work? Yes, it does work. It does work. And if you print, it is going to print you these values as well, right? But then how is it even working? Can you try and relate to it? Std is object of class b, and we are writing std.name. But do you see any name defined inside class b? There's no name defined inside class b. There is just gender. So how is this statement running? How is std.name is equal to arun.padar not giving you any error? What do you think? It is working. Anyone? So this is working because name and age both got inherited inside class B. So even if in the definition you do not see this, it is actually both of these are available inside class B as well, right? So std.name is equal to Arun Podar, std.age is equal to 23, std.gender is equal to male. All of these are going to work, and when you print these, this is going to give you the outcome as well, right? So this is actually an example of a simple inheritance. How is this possible? This is the only change that we have made, right? While defining the child class, we have specified under brackets the name of the parent class, right? So any questions with simple inheritance, guys? Do let me know.
No.
Okay, right. So that makes us move to the next topic, which is primarily our last topic for today is how do we do multiple inheritance, right? So let me show you really quickly what I have already explained to you. So multiple inheritance is this example, right? Where we are not only extending from one class or we are not inheriting from one class. Now this class, which is a child class, is inheriting from multiple classes at once, right? To give you an example, this is a person which is inheriting uh, stuff from maternal as well as paternal side, right? So how do we do that? If you understand this concept, the only thing that you need to actually know is how this is going to be syntactically written, right? The rest of it is going to be the same. So again, for simplicity's sake, I have taken a very simple example of a class A, and we have two variables defined here, name and age, and then class B where we have defined gender, right? Class A, name and age, class B, gender. Now look at this. How is this syntax different from the earlier statement, right? In the case of a simple inheritance, we had just defined one class, right? Why? Because simple inheritance is all about inheriting one class. In multiple inheritance, we inherit more than one classes. So what we have done, instead of defining just one class, here in the case of multiple inheritance, we have defined more than one classes. Now, can it be three classes? Yes, the answer is yes. Can it be four classes? Yes, it could be any number of classes. So now if you look at class C, it only has a function, right? Is senior citizen. It does not have any variables. It does not have name defined. It does not have age defined. It also does not have gender defined. But class C is inheriting both of these classes, class A and class B. So what does it mean? It has name, age, and gender, all of these available with us. So let us make sure that this statement is true, right? And how do we do that? Now, if you look at this, right, in case of inheritance, we always try and create the object of the inheriting class, the class which inherits the other classes, right? So here we had created the object of class B. Now we are going to create the object of class C, right? So let's see. Now we are defining a student. Std is equal to C, and then if you look at C, there is no name, there is no age, and there is no gender, right? It does have just a function, but still I am able to call std.name is equal to, and I can specify a name. I am able to call std.age, and I'm able to specify age, and then I'm also able to do std.gender. And this statement runs correctly, perfectly fine, no errors in there. And when you print this std.name, age, gender, and is senior citizen, right? How are we printing this? We are printing this through, or we are calling this through the object of the class C. And using this, you can call name, age, gender, as well as is senior citizens. And if you look at it, is senior citizen function is part of class C, and then the rest of them are part of class B or A. Still, we are able to call all of these using object of the class C because they are all inherited into class C as well. Right? Getting what I'm trying to explain, guys?
Yeah. Yes.
Yeah. And that way, likewise, right, depending on what your need is, the implementation could be different as well. So you can have a implementation where we are, having this kind of a, we are having this kind of a, you know, implementation. This we can do as well. If you, yeah, so it totally depends on what exactly you need. You can have this kind of implementation as well. So it totally depends on what exactly you need. The syntax, which we have already shown you, is how uh, it can be defined. If you need to do inheritance while defining a class, you just specify all the classes with the class definition that you want to inherit in this class. And this is an easy way to do this. So in all likelihood, if you believe that this is slightly little complicated, trust me, guys, this is the core of object-oriented programming. It may not be so highly required for you guys if you're doing, or if you're going to use Python for doing your exploratory data analysis or any kind of a data analytics, or maybe for visualization or database programming or file handling. But knowing this concept is definitely going to make your overall knowledge of Python a more comprehensive one, right? So at any given point in time, you should not be having any kind of a knowledge gaps, and knowing about classes is definitely one of the prerequisites that you should have. So with this, guys, I'm pretty much done with today's session.